Hello everyone, my name is Rani. I am studying at Institute of Aeronautical Engineering, BTech second year, CSE. So today I am going to give presentation on the history of semiconductor memory from magnetic tape to NAND flash memory. So let's go. Contents are introduction, types of semiconductors, magnetic tapes, flash memories, and limitations of flash memories. Introduction. Semiconductor memory is a digital electronic semiconductor device used for digital data storage, such as computer memory. It typically refers to MOS memory, nothing but metal oxide semiconductor, where data is stored within metal oxide semiconductor. MOS. Memory cells on a silicon integrated circuit memory chip. There are numerous different types using different semiconductor technologies. The two main types of random access memory are static RAM, that is SRAM, which uses several MOS transistors per memory cell, and dynamic RAM, which is nothing but DRAM, which uses a transistor and a MOS capacitor per cell. Non-volatile memory, such as EEPROM, double EEPROM, and flash memory. EEPROM is nothing but erasable, programmable, read-only memory. Double EEPROM in the sense electrically erasable, programmable, read-only memory, and a flash memory. Using floating gate memory cells, which consist of a single floating gate MOS transistor per cell. So, in types of semiconductors, memories. So, in the types of semiconductors, we have mainly two types. Means it's classified into two types. That is volatile and non-volatile. Volatile, in the sense, if when the power is lost, the data will be lost. When the power is off, the data will be lost. But in non-volatile memory, if the power is lost, if the power is off, the data will be remain. The data will be retained. Means it has the ability to regain the data which has been uh, when the power is off. So under volatile memory, there will be a RAM is nothing but random access memory, in which we have two types, that is DRAM, SRAM. In the sense, DRAM in the sense dynamic random access memory, and SRAM in the sense static random access memory. And again, DRAM we have two types, that is SDRAM and mobile RAM. SDRAM and mobile RAM. This is the last one for volatile. And coming back to the non-volatile memories. Non-volatile memories, we have mainly six types, which is floating gate, nitride, flash, ROM and fuse, emerging, and the last one is others new, which are newly evaluated. So under flash we have again two, that is NAND and NOR, ROM and fuse. Under ROM and fuse we have E double EEPROM, EEPROM and double EEPROM. So again in emerging we have seven types. They are racetrack, double RAM, STT RAM, FE RAM, PCM, and the last one is polymer. And the last in the others new, we have zero RAM, nano bridge, CMO, Q dots, multiped, 3D, molecular, nanomech, transparent flexible, CMO RAM, CMO, MTM, and SPB double M. So these are the types of semiconductors memories which are related, which are basically classified as from volatile and non-volatile. Means based on the power supply, means when the power is off, the data is lost, the data is gained. Based on that, these are classified. Okay. And let's see next slide. So yeah, the semiconductor memory is a type of semiconductor device tasked with storing data. Means it's nothing but storing the data. It may be a permanently or a temporarily. And there are two electronic data storage mediums that we can utilize. They are magnetic or optical. Magnetic storage stores data in magnetic form, means it stores data in the form of magnetic. Okay. Affected by magnetic fields, means affected by magnetic fields, has high storage capacity, doesn't use a laser to read and write data. Yes, it mainly uses magnetic. And the examples of these are magnetic storage devices are hard disk, floppy disk, magnetic tape, and etc. And next ones are optical storage. Stores data optically using lasers. Means in this optical storage we uses they uses lasers. Stores data optically, uses laser to read and write. Not affected by magnetic fields. These are not affected by the magnetic fields. Magnetic storage devices are affected by magnetic fields. Has less storage than a hard disk. Means it has less capacity, storage capacity than magnetic storage devices like hard disk. Data accessing is high compared to floppy disk. It access data more faster than floppy disk. Optical storage devices are CD-ROM, CDR, CDRW, DVD, etc. There is also volatile memory. This is memory that loses its data once power is cut off, while non-volatile memory retains data even without power. As I said before about the volatile and non-volatile, by using we have also seen the different memory devices classified from that. And as we seen in volatile we have a RAM, and in non-volatile we have a ROM and all other things. So let's see next one. Magnetic tapes. As we seen, a magnetic tape is an example of magnetic storage device, right? So in magnetic tape, only one side of the ribbon is used for storing data. It is a sequentially memory which contains thin plastic ribbon to store data and coated by a magnetic oxide. Data read write speed is slower because of the sequential access. Means it accesses sequentially, means linearly. It is highly reliable, which requires magnetic tape drive, writing and reading data. And the examples of magnetic tapes are videotape, audio tape, and computer data tape are examples of magnetic tape. Under magnetic storage device, we get magnetic tapes. Under magnetic tapes, we get video tape, audio tape, computer data type. Okay. So next one is flash memory. Flash memory is an electronic, non-volatile computer memory storage medium that can be electrically erased and reprogrammed. Non-volatile in the sense it can retain the data when the power supply is off. Okay, this is non-volatile computer memory storage medium that can be electrically erased and reprogrammed. We can erase it and reprogram it also by using electrically. The two main types of flash memories are NOR flash and NAND flash, are named for the NOR and NAND logic gates. By using NOR and NAND logic gates, both use the same cell design consisting of floating gate MOS FETs. They differ at the circuit level depending on whether the state of the bit line or word lines is pulled high or low. In NAND flash, the relationship between the bit lines and word lines resembles. Uh, in NAND slash, in NOR slash, it resembles a NOR gate. And limitations of flash memory. Although flash memory gives many advantages, yet it has some flaws. It cannot erase a byte or a word at a time, but it can erase a block. Means it erases the data in the form of taking a block of data. It cannot erase the single line or a single word in such a way. But bit flipping occurs. The bits gets reversed and create errors. We have bits like a binary bits. When the data storage happens, bit flipping occurs. One can be replaced with zero, zero can be replaced with one. In such a way, the data is flipped. Then of course 1001 is not same, right? So then the errors occurs, it gets reversed and creates an error, which is not good, which is not a good quality of a memory, right? So these are the flash memory limitations. And magnetic tapes we have discussed in this ppt. We have discussed about introduction, types of semiconductors, introduction of the semiconductors, what are RAM, SRAM, DRAM, and metal oxide semiconductors, and types of semiconductors memories by volatile and non-volatile. Again in volatile we have RAM, as we seen, DRAM, SRAM. Again in DRAM we have again SDRAM, and such a way again we have mobile DRAM. Again in volatile we have a flash ROM, EEPROM, double EEPROM, EROM, and double EROM. And what is magnetic difference between magnetic storage and optical storage? Means in magnetic storage, by using magnetic fields, the data will be affected, but in optical storage the data will be affected by using the lasers. And in magnetic storage capacity, data storage capacity is high, but in the optical storage it is less. And the examples of magnetic storage are hard disk, floppy disk, magnetic tape. Coming to the optical storage, we have by using lasers, read and write operations will be done, and less storage, as I said, and not affected by magnetic fields. And examples of optical storage are CD-ROM, CDR, CD-RW, DVD, and we have seen volatile and non-volatile. And magnetic tapes. Sequentially the data will be allocated, the memory will be then in sequential order. And is slower. data read Data read write speed is slower because of sequential access. And examples of magnetic tapes are video tapes, audio tapes, and computer data tapes are examples of magnetic tapes. And we saw flash memory. In flash memory, it is a non-volatile memory, and it can be electrically erased and reprogrammable. And it has two types, that is NOR and NAND, by using the gates of NOR and NAND. And we have seen this and about the cell design. And coming to limitations, it has only two limitations, that is it cannot erase the data single byte or a word. It erases the data in a block of code, in such a way. And bit flipping occurs. The If data gets reversed, it creates an error. The bit flipping will occur in flash memory. That are the limitations of flash memory. And thank you.